Midline theorem. Learning target. I can solve for the measures of the midline of a triangle and of a trapezoid. Midline is a line that connects the midpoints of the legs of a triangle or a trapezoid. In solving for the measure of the midline theorem is used. So here in our given figure, line inside the triangle is midline because it connects the two midpoints of the sides of triangles, and also the line segment inside the trapezoid is a midline because it connects two midpoints of the legs. Midline theorem for triangle. It states that the midline of a triangle is parallel to the third side and half as long. For example, a given triangle ABC with midline DE. According to theorem, midline DE is parallel to its third side BC. And also, the measure of midline DE is half as long as the measure of the third side BC. So DE is equal to 1/2 the measure of BC. For example, given triangle ABC with DE and F are midpoints of AB, AC, and BC respectively. If AB equals 28 centimeters and AC is 51 centimeters and BC is 32 centimeters. Now, what are the measures of DE, EF, and DF? Okay, so we are asked to find the measure of our three midlines, DE, EF, and DF. Okay, let's start with midline DE. Now, to find the measure of midline DE, we will apply the midline theorem for triangle. So, midline or measure of midline is just 1/2 the measure of third side. So, if it is our midline, then the third side is side BC. So, therefore, DE is equal to 1/2 the measure of BC. Substitute the measure of BC. So, DE is equal to 1/2. BC is 32 and 1/2 of 32 is 16 centimeters. So measure of midline DE is 16 centimeters. Next, midline EF. So to get the measure of midline EF, it's just 1/2 the measure of the third side. So here's our midline EF. It should be parallel to our third side AB. So midline EF is equal to 1/2 the measure of AB, which is 28 centimeters, and 1/2 of 28 is 14 centimeters. Therefore, measure of midline EF is 14 centimeters. Next, midline DF is 1/2 its third side. So midline DF is parallel to our third side AC, and the measure of AC is 51. Okay, so we have DF is equal to 1/2 51, and the 1/2 of 51 is 25.5 centimeters. So measure of midlines DE, EF, and DF are 16, 14, and 25.5 centimeters respectively. Another example, given triangle PSD with Q and R are midpoints. So PQ is congruent to QS and PR is also congruent to RT. If QR is 2x plus 1 centimeters and ST is 5x minus 1 centimeters, what are the measures of QR and ST? So we are asked to find the measure of the midline QR and its third side ST. Now, to get the exact measurement of QR and ST, we need to get the value of X. And in order to get the value of X, we will just apply the midline theorem for triangle. So midline QR is just 1/2 the measure of the third side, ST. Substitute the given values. QR is 2x plus 1, while ST is 5x minus 1. Cancel fraction 1/2, multiply both sides of the equation by the reciprocal of 1/2, which is 2, and 1/2 cancel, 5x minus 1 is equal to, distribute 2 to each expression on the left side. So 2 times 2x is 4x, and 2 times 1 is 2. Solve for x, transpose 4x on the right side of the equation. So from positive, this will become negative 4x. Again, transpose negative 1. From negative, that will become positive 1. 5x minus 4x is x, and 2 plus 1 is 3. So the value of variable x is 3. Now to solve for QR, just substitute the value of variable x, 3. So 2x plus 1 will become 2 times 3 plus 1. 2 times 3 is 6 plus 1. QR is 7 centimeters. And for our third side ST, we have 5x minus 1, or 5 times 3 minus 1. 5 times 3 is 15 minus 1, 14 centimeters. So measures of our midline QR and third side ST are 7 and 14 centimeters respectively. Now let's move on to the midline theorem for trapezoid. It states that the midline of a trapezoid is parallel to the bases and its length is half the sum of the lengths of the bases. So for example, given trapezoid ABCD with EF as midline. So here, according to theorem, midline EF is just parallel to our bases AB and DC. So EF is parallel to AB and also parallel to side DC. Now when it comes to measurement, the measure of our midline EF is just 1/2 the sum of the lengths of the bases. So we have 1/2 times the quantity AB plus DC. Again, measure of midline in a trapezoid is equal to 1/2 the sum of the bases. For example, given trapezoid ABCD with E and F are midpoints, so therefore EF is a midline. If AB is 51 centimeters, DC is 84 centimeters. Now what is the measure of midline EF? So apply midline theorem for trapezoid. EF is equal to 1/2 the sum of the bases AB and DC. Substitute the values. 1/2 AB is 51, DC is 84. Okay, we have 1/2. 51 plus 84 is 135. 1 plus 4 is 5. 5 plus 8 is 13. And the 1/2 of 135 is 67.5. So measure of our midline EF is 67.5 centimeters. Another example, given trapezoid QRST with UV are midpoints of Q2 and RS respectively. So UV is a midline. If QR is 3x minus 10 and UV is 3x plus 6, while TS is 5x minus 12 units, what are the measures of QR, UV, and TS? So given the bases and the midline of a trapezoid, just apply the theorem to get the equation, okay, and to solve for the variable x. So midline UV is just equal to 1/2 the sum of the bases QR and TS. UV is 3x plus 6 equals 1/2. QR is 3x minus 10 plus TS 5x minus 12. Simplify the expression inside the bracket. Okay, so we have 3x plus 5x is 8x, negative 10 plus negative 12 is negative 22, equals 3x plus 6. Now, cancel fraction 1/2 by multiplying both sides of the equation by the reciprocal of 1/2, which is 2. Okay, distribute 2 to each term. On the left side of the equation, 2 times 3x is 6x, and 2 times 6 is 12. Now, cancel 1/2 on the right side, 8x minus 22. Solve for x, transpose 6x. We have 8x, and then from positive 6x, this will become negative. Negative 22 will become positive when transposed on the left side. Okay, so we have 12 plus 22 is 34, equals 8x minus 6x is 2x. Now divide both sides of the equation by 2. The value of our variable x is 17. Now solve for QR, UV, and ST by just simply substituting the value of x. So for QR, we have 3 times 17 minus 10. The answer is 41 units. Next, substitute 17 to the given expression for UB. Okay, we have 3x or 3 times 17 plus 6. We get 57 units. Now substitute 17 to the expression for TS. 5 times 17 minus 12. That is 73 units. So the measure of QR, UV, and TS are 41, 57, and 73 units respectively. That's all for our lesson, Midline Theorem. Thank you for listening.